Hi, this is Dr. Kell, and I'm going to be going over today the notes for lesson 6.0, and we're going to start with a review of radicals and proportions. First of all is a ratio. A ratio is a relationship of two numbers. And a ratio can be written as a fraction. It can be written in words, or it can be written with a colon, okay? So for example, I can say like 3 boys to 4 girls, okay? I could say something like that. I could also write it as a fraction, 3 boys to 4 girls, or I could write it as a colon, and each one means the same thing, okay? A proportion is when we take 2 or more ratios and set them equal to one another, okay? So, for example, I could say like the 3 boys to 4 girls, this would be the same thing as how many boys to 12 girls, or something like that. Or I could say anything along that line, okay? So what this creates here is is something that has to be is something that has to be solved. Okay. So when we solve proportions, like if I wanted to say how many boys would there be if there were 12 girls, what I have to do is cross multiply. Okay. So a lot of times, like in middle school, they do this like butterfly situation. Okay, I don't usually show it that way. I usually go like this. I cross multiply and I show it with arrows. Okay, so so you would cross multiply. Okay, so this would be in this example that we're looking at right here. It would be 3 times 12 is equal to 4 times x, okay? So you would set the products from step 1 equal to each other, and then we could solve this for this variable. So here I could say 36 is equal to 4x, and I could solve for x by dividing by 4, which would be 9. X is equal to 9. I'm a little bit out of room there. But for example, we're going to do a few more examples here, okay? So to solve a proportion, you're going to cross multiply. Think the butterflies that you might have learned in middle school. And you're going to set those products equal to one another and then solve for your variable, okay? So I'm going to zoom in here to number 1, okay? So I am going to cross multiply. I was thinking about the next one in my head. And I know that 7 times 4 is 28. 9 times x is just 9x, okay? And now I'm going to get x by itself by just dividing both sides by 9, okay? So you could leave this as a fraction if you wanted to. You could write it as a decimal. Either way is fine, okay? So I'm going to do one more example, and then I'm going to have you guys pause the video and try a few on your own. Okay, so in this example, we're going to cross multiply again, but I want you to like seriously star this. Okay, do you see how this is a binomial here? We have b minus 2. It's not like it's just b or something by itself, but it's a binomial. You must remember to distribute in this situation, okay? It's a super common mistake to forget that, but the reality is we're going to multiply 5 times all of that, okay? So this is going to result in 5 times b minus 2 is equal to 6 times 3 is 18, okay? In this situation, we are going to distribute. And now we're going to go ahead and solve for the variable. I'm going to add 10 to both sides. And I'm going to try to get my computer better here. I get 5b is equal to 28. and I'm going to go and divide both sides by 5, and I get b is equal to, 28 over 5, or whatever that is, 5.2 or something, 5.3, what is it, 5.6. Okay, either way is fine. Okay, so let's go ahead and look here. I want you guys seriously pause. Why is it doing that? I want you to pause and try these on your own. Okay. Okay, so when you pause it and come back in a second, and you'll see the answers. Okay, so hopefully you actually did pause it and try on your own, but here are the answers for number 3. You should have gotten that D is 3.75 and Y is negative about 1.5. It's rounded, but it should be something along that line. If you have questions on this, like if you did try it on your own and you got stuck and you couldn't get this answer, this is a good thing to like star and ask your peer tutor about, or ask your teacher or your or friend or something, okay? So let's go ahead and look at this, solving this proportion. I'm going to have you guys do this one on your own as well, and then come back to it. But in this one, it's the same process. You're going to cross multiply, but just be careful because you're going to have to distribute twice. Okay, so if you solve through for number 5, the big trick here is that you have to distribute on both sides here. And you're going to combine like terms and go through the algebra, and you should ultimately get that h is negative 46 over 7 or negative 6.6. Okay, again, if you can't figure out, you can't follow this, pause again, try to correct your work. But if you still need help, go ahead and ask your peer tutor for some help. Okay, so we're going to look at simplifying radicals. Okay, you are going to simplify a radical, you are going to do prime factorization. Okay, that is what it is called, prime factorization. I don't know why I put an exclamation point. You don't need it. Okay, so you are going to factor inside the radical to all prime numbers. And then you're going to look for pairs to remove from the radical. Y'all, I promise my handwriting isn't normally this bad. It's like I'm writing on a vertical surface instead of a flat surface, and it's super annoying. Okay, so let me think of one that maybe we all know, okay? So maybe I'm going to look at an example like the square root of, let's do 49. Okay, well, I like to do this little tree, okay? Well, so what are the factors of 49? Well, the factors of 49 are 7 and 7. And now you're to prime numbers. You can stop there, okay? If that was an even number, we would continue to factor, okay? Because these are prime numbers, and I have a pair of those prime numbers, those numbers simplify out of the radical, and then nobody is left inside in this case, okay? Maybe if but you can do that one in your head. You know, square root of 49 is a perfect square. You should know how to do that one. But what if I had maybe, I don't know, let me try, I'm bad at making up examples. Let me try a square root of 90. Okay, so you're going to factor 90 to your prime factors. There's a lot of ways you can do that. You could do 45 and 2. I'm going to go with 9 and 10. Okay, these are not prime. Neither of these are prime. So we're going to continue to factor 9 factors to 3 and 3. Hey, 3 and 3 are both prime. That's the end of that branch. 10 factors to 2 and 5. 2 is prime and 5 is prime. That's the end of that branch. Okay. So what we're going to do is we're looking for pairs, okay? There's a pair of 3's. Those 3's simplify out of the radical. It's a perfect square that simplifies out of the radical. The 5 and the 2, they do not simplify out of the radical. They stay in the radical, but they get multiplied back together inside the radical. So square root of 90 in simplified radical form is 3 square roots of 10. Okay, so we're going to do a couple more examples here and then have you guys try a number on your own. Okay, so square root of 54, what is that? It's 27, I think. Yep, 2 and 27. Okay, 27, 2 is done. That's the end of that branch. 27 factors to 3 and 9. 9 factors to 3 and 3. Okay, so we have a pair of 3's that get to simplify out of the radicals. Okay, it comes out as just a single 3. Okay, and then anybody that didn't have a buddy multiplies back together. If it's at the end of the branch, if it didn't have a buddy, it multiplies back together inside of the radical. Okay, so square root of 54 is the same thing as 3 square roots of 6. Okay, going to move on over here. Okay, so this -7 is outside the radical. He's just going to hang out there until we get anybody else outside the radical. So the square root of 300, I'm going to factor two prime numbers. I don't know, let's do, what do you think, 30 and 10. 30 is 10 and 3. 10 is 2 and 5. This 10 is 2 and 5. So now at the end of the branches, I have all prime numbers. Each of these, 2, 5, 3, 2, 5, these are each prime numbers. Okay, anybody that has a pair gets to be removed from the radical. But the thing is that -7 is already living outside there. Okay, so the 2's have a pair, so the 2 gets to factor out of the radical. This 5's have a pair, so that 5 gets to, simplify outside of the radical. This 3 right here did not have any buddies, so he's going to stay living inside of the radical. Okay, that -7 and 2 and 5 all multiply together on the outside, so this becomes -70 square root of 3. And this is the most simplified radical form. Okay, so again, oh, we already did square root of 90. Well, try it again on your own. I should have looked ahead, but go ahead and try these two on your own and then come back after you're done. Okay, so 9 and 10, we already did square root of 90 in an example earlier, but it should be 3 square roots of 10. And number 9, after you simplify it through, should be 20 square root of 3. Okay, again, questions, direct them to your peer tutor or your teacher. Okay, so dividing radicals, okay? So the process for dividing, for when we have radicals that are a quotient, the first thing you always want to do is you want to simplify if possible. Okay, always want to simplify, okay? Then you want to, like this would be to like reduce fractions. Okay, then you want to simplify the radicals. And then if you need to, you're going to have to do this thing, if you remember from Algebra 1, which is rationalize the denominator. Okay, rationalize the denominator. Let me try to write a little bit better. Okay. Okay, so for example, I'm bad at making up examples. So I don't know, maybe I have the square root of 81 over 9. Okay, well, okay, square root of 81 over 9, I don't know, but I do see that this fraction right here can simplify, okay? So I'm going to go ahead and do that first if I ever can. 81 divided by 9, well, that's just 9, okay? So that part is done. Now I can simplify that radical, where the square root of 9 is, its prime factorization is just 3 times 3, but you should have this one in your head. The square root of 9 is just 3, okay? In this case, we don't have to rationalize the denominator. Okay, so let's go ahead and look at 10, 11, 12. And hey, you guys, if you are like, yeah, I don't remember at all rationalizing the denominator, go ahead and, you feel free to Google it. Feel free to look back at anything you might have kept from Algebra 1. It is something that you have learned before. All of this is. So if you're still feeling lost, go ahead and look back on stuff you have done previously. Okay, so square root of 16 over 25. Okay, so first of all, does that fraction reduce? It does not. Okay, so what I'm going to go ahead and remember, let me add one thing back here actually. Okay, so one thing, I'm going to do it in a different color, is that if you have the square root of a over b, that's the same thing as the square root of a over the square root of b. Okay, so if it's under one radical, you can break it up into 2 radicals. Okay, so for this example here, what I could have done is I could have said that this is the square root of 81 over the square root of 9, and it would have worked out to be the same answer. Okay, so I'm going to zoom in over here. Okay, so in this case, because 16 and 25 don't reduce, I'm going to break this up into 2 different radicals. I'm going to write this as square root of 16 over the square root of 25. Okay, and I'm going to simplify each of those radicals independently. The square root of 16 is just 4. The square root of 25 is just 5. Hey, I'm done. Okay, that is finished. Okay. Okay, so I'm going to move over here. Square root of 4 over square root of 49. Well, I know what the square root of 4 is. It's 2. And I know that the square root of 49 is just 7. That one is also done. Okay. Okay, so square root of 50 over square root of 18. Listen, there are a bunch of ways you could approach this. For me, I want to simplify any fractions first. If your teacher does it differently, then that is completely fine. But I'm going to write it under one radical. That way it's easier for me to see that this simplifies, okay? So what I can see here is that these are both divisible by 2. 2 goes into 50 25 times, and 2 goes into 18 9 times, okay? So that made this way easier, because now when I write this as 2 different radicals, I can easily see that those are each perfect squares and simplify to 5 over 3. The reality is, when you guys get more accustomed to this, you will be doing a lot of this in your head. When I show this, I show every step, but when you do it on your own, you'll be skipping steps in your head. Okay, you guys know the drill. Pause the video and come back when this is done. Okay, hopefully you tried this on your own. The square root of 100 over 49 is just the same thing as the square root of 100 over the square root of 49, which is 10 over 7. Square root of 121 is 11, square root of 64 is 8. And now square root of 3 over square roots of 12. A couple of ways you can do this. The way that I would do this is I would simplify 3 and 12. I know that that's going to reduce to 1 and 4. Okay, square root of 1 is 1, square root of 4 is 2. So the ultimate answer is this reduces to 1/2. Okay. Okay, so we are on the last little topic of our little review unit. Okay, we're going to look at rationalizing denominators. Okay, so here is the deal, you guys. We can have no radicals in the denominator. Okay, that is a rule of math. Till math do you part. There never, ever, ever should be a radical in the denominator. So in order to get rid of the radical in the denominator, you're going to multiply by 1, the number 1, in radical form. Okay, this will make more sense in a minute, okay? And then you're going to simplify the radical. Okay, so if I have something like, I don't know, let me just make one up. 1 over, let me just make it, I don't know, 2 over the square root of 3, okay? It is not okay to have that square root of 3 in the denominator. It's just, one of those things. It's bad manners in math, okay? So I'm going to multiply by 1, okay? When I multiply by 1, I'm not changing a value. I'm just changing the form. In this case, the version of 1 that will be useful to me is square root of 3 over square root of 3, okay? Square root of 3 over square root of 3. You guys, this is just the number 1. That's it. Okay? It makes it, we're not changing any values. We are just multiplying by 1 in a specific form. Now I'm going to multiply numerator times numerator. This is 2 times the square root of 3. And I'm going to multiply denominator times denominator. Square root of 3 times square root of 3 is the square root of 9. Okay? 2 square root of 3, can't do anything with that. Square root of 9, though, is just 3, okay? And now this is okay. I no longer have a radical in the denominator, okay? So I'm going to go through a couple examples here. Oh, of course, it's square root of 3 again. So in this one, I'm going to multiply 1 in the form of square root of 3 over square root of 3. 1 times the square root of 3 is just the square root of 3. Square root of 3 times square root of 3 is the square root of 9, which is just 3. In reality, as you are getting used to this, you're going to be able to skip some steps and get to that denominator without showing the work. Okay, maybe I'll do one more showing it and then I'll skip it on the next one. Okay. So again, you guys, I'm going fast because I don't want this to be like a 30 million year long video, but pause when you need to. Okay, I'm multiplying by 1 in the form of square root of 5 over square root of 5. Okay, so I have 4 square root of 5 in the numerator. Square root of 25 is just 5. And so now that is done. I can't simplify any further. Okay, so hopefully at this point you're seeing the pattern of what happens here with the denominator. That's why we're doing this, to get rid of that radical. I'm going to go ahead and skip the middle step for this one. And that way you can see what I mean. 6 times the square root of 2 is just 6 square root of 2. Okay, we do not multiply. This does not become square root of 12 or something like that. We cannot multiply into the radical. That denominator becomes just 2. It would be the square root of 4, which is 2. Hey, in this case, we're not done because I can simplify that. 2 goes into 2 once, 2 goes into 6 3 times, and this becomes 3 square root of 2 as my final answer. Okay. One more. And you guys just remember that if something is in the radical, it doesn't hang out with things that are outside the radical. You can't multiply just a number with a radical. They don't combine like that. It would always stay on the outside, okay? So if you're confused, then yeah, just make sure to talk to your teacher. Okay, so I'm going to multiply by 1 in the form of square root of 10 over square root of 10. This becomes 10 square root of 10, okay? Square root of 10 times square root of 10 is square root of 100. Square root of 100 is just 10. Hey, and now this simplifies here. 10 goes into itself one time in both cases. And this is just the square root of 10. And that is my answer. All right, you guys, pause the video. I'll put the answers up here, and then that will be the end of 6.0. Okay, number 20 simplifies to just square root of 13 over 13. Number 21 simplifies to 7 square root of 6 over 6. Number 22 is 6 square roots of 3. And number 23 simplifies to just the square root of 14. Okay, I will zoom out. You guys, take a lot of ownership in your learning when you're watching these videos, okay? Pause when you need to. Write down the individual questions that you might need, and just make sure you, you're an active learner even when you're doing these videos, okay? This concludes 6.0. Have a good day.